Hi everyone. Okay, so this is going to be the second half of our binomial distribution discussion. All right, so we're going to do two things today. We're going to graph and draw a graph of our probability distribution of a binomial. So we're going to create the binomial probability distribution. We're going to graph it, and then we're going to find some probabilities as well as find the mean, variance, and standard deviation of our binomial distribution. That is a lot easier than doing the regular probability distribution, no charts or anything else. It's here's the formula, put the numbers in, get an answer. It's going to be a lot easier than what we did with regular distributions. All right, so a probability distribution for a binomial is just like it was before. It is using x and p of x to create a distribution. All right, so basically, it's all of the random variables for each random variable along with its probability. Okay, it's the random variable. It's the binomial random variable. With its probabilities. Okay, so again, we're going to make a chart. Okay, so x, remember, is our random variable. That's going to be from 0 to whatever. Okay, so this is going to be your actual, like, starting at 0 and writing all of them, whatever it happens to be. If there's 7 successes or 7 things in our trial, it would be 0 to 7. This is our p of x, which we can get either via the website or using your calculator. But you're going to find the probability of each one of those. And then that's going to help you find some probabilities when we ask some questions. All right, so let's take a look at an example. So in a survey, U.S. adults were asked to identify which social media platform they use. The results are shown in our figure here. 6 adults who participated in the survey were randomly selected and asked whether they use social media from Facebook, the old people one. Construct a binomial distribution for the number of adults who responded yes. So this is a binomial, even though you have multiple choices, it's either Facebook or not Facebook. So those are your two choices, and that's why this is going to be considered a binomial. All right, so let's identify N, P, Q, and X. So N, okay, so remember, is 6 adults, because that's how many we talked to in our survey. Probability of success is going to come over from over here at Facebook, so 0.68. Remember, Q is the probability of failure, which is 1 minus 0.68, or 0.32. And X is going to assume values from 0 to 6. Okay, so let's construct our distribution. You know what? I'm going to move these down here so I have more room to work. Okay, so let's make our distribution. So x is our random variable, and this is p of x, which is our probability. So we're going to go from 0 to 6, and then we're going to find the probability of each one of these. Now, you have a choice on, again, how you want to get there. You can either use the formula, you can use your calculator, or you can use the website. Again, your choice. So pick whichever one. Again, I'm going to use the website because that's probably the easiest. Oops, excuse me. I don't know why I did that. I may have to use my calculator. All right, so let me give you those probabilities. So 0 was 0.001, 0.014, 0.073, 0.206, 4, 0.328, 0.279, and 0.099. And there's your distribution. Okay, so it doesn't seem too difficult. Again, use the website, use the formula, or use your graphing calculator if you have access. All right. So let's try the next one. We have a survey here of 17% of US adults say that Google News is a major source of news for them. You randomly select 4 and ask whether Google News is a major source. So again, it's binomial. We have 4 people participating, so that's the number of trials. 0.17 is going to be our P. Our Q is going to be 0.83. And our X is going to assume values from 0 to 4. Okay, so let's write that down. So N is 4, P 0.17, Q 0.83, and X is going to go from 0 to 4. Okay, so let's make our distribution. So X and P of X, 0, 1, 2, 3, and 4. Okay, now again, I'm going to use my calculator this time because I don't know if the websites work. I don't know what I did with the website. Let's try that out again. Okay. Why did we just not? All right. So obviously I did something. Let's try going through Schoology. All right. I must have did something. Okay. So it's in your... Oh, there we go. Okay, it's in the week. See, it says binomial probability calculator. So if it shows up here, then you can just use this go to website, open in Safari. There we are. Okay, so 0.17 is our success. Okay, number of trials is 4. And number of successes, we're going to start with 0. Unfortunately, you have to do every single one. There's no shortcut here, guys. You actually have to physically do 0, 1, 2, 3, and 4. Okay, so 0 is 0.47. Okay. Okay, 1 would be... Oop, I thought I had that. All right, so... .38 or 39, 389 or 39. Let's just go 39. Okay, we're going to do the same thing with 2. 0.12, same thing with 3. 0.01, 0.02, and 4. Okay, now if you're using a calculator or anything, it may give you scientific notation. Just be aware of that. So 0.0008. Okay, there we go. Now we're just going to graph like we did the other day with our probability distributions. So I'm just going to make my little graph here. And we're going to go from 0 to 4 on my horizontal. And my vertical is going to be P of X. Okay, and these are really super, super small. So let's make this 0.5. All right, so 0 was 0.47. Okay, 0.39, almost 0.4. There we go. Okay, 0.12. 0.02. Oof. And this is like right on top of the axis. There we go. So in this case, our binomial decreased. It's definitely skewed right. Okay. All right, so we're going to do some probabilities now. Okay, so once you make your distribution, you have all the information you need to answer any of these questions. All right, so if I wanted to find exactly 2 of them responded yes, so let's say x is equal to 2, I'm just going to come up here, it's 0.12. Okay, at least 2 of them responded yes. Now remember, at least means 2 or more. So there's a couple ways you can do this. You can go 2 plus 3 plus 4. You can do 1 minus 0 and 1. You have a couple of choices. So I'm going to do 2 plus 3 plus 4. So x equaling 2 plus x equaling 3 plus x equaling 4. Okay, and then I'm just going to add them up. So 0.1, 0.02, 0.12, 0.02, and plus the one that's really small, 1, 2, 3, 8. Okay, so I got 0.1408. Now you can use that graphing or that stat app that I showed you. Okay, so right here, okay, we have. Here you are. Now we want to be at least 2, so that's greater than or equal to 2. So if I change that to number of successes to 2, okay. Okay, greater than or equal to 2 would be 0.1, is that right? 0.17, 0.136. I don't think that's the same. 0.137. Well, I messed up something. I think this, did I do a different problem? Well, I'm going to go with 0.1408. Fewer than 2 would be 0 and 1. So I would add those 2 together. So 0.47 and 0.39. So 0.47 plus 0.39, 0.86. So 86%. All right, so I would try using that calculator, or you can Google another one, or if you have access to a graphing calculator, I would use that. All right, so hopefully that made sense. All right, so when we talk about mean and variance and standard deviation, it's a lot easier than what we did before. So mu is just n times p. Omega squared is npq, and omega is the square root of that. Okay, so remember, this is mean, this is variance, and this is your standard deviation. Okay? All right, so let's try this problem. So in Pittsburgh, PA, about 56% of the days are cloudy, in a year are cloudy. Find the mean, variance, and standard deviation for the number of cloudy days during the month of June. Interpret your results and determine if any of them are unusual. All right, so let's talk about how we're going to do this. So let's talk about mean. Okay, so our mean, well, again, before we do anything, let's do n. So how many days are in June? 30. P, success, is 0.56. Q is 0.44. And our X goes from 0 to 30. Okay, 0 cloudy days to up to 30 cloudy days. All right, so let's do mean. That's NP. So 30 times 0.56. Okay, so 16.8, and that means that the average number of cloudy days in June is 16.8 days. So our variance is NPQ. So 30 times 0.56 times 0.44 is 7.4. And then our standard deviation, omega, is the square root of that. So that's the square root of 7.4. So we're going to get 2.7. All right, so let's talk about how, any questions there, please, again, let me know. Let's talk about how we would interpret this. So we would say on average, or we can expect, because remember, average in probability distribution is the same thing as expected value. There are 16.8 cloudy days during the month of June. Okay. Okay. And then we'd also include the standard deviation is 2.7 days. Okay, so are any of the days unusual? Anybody who's more than 2 standard deviations away from the mean is going to be considered unusual. So I'm going to take 16.8 and add 2 times 2.7. And I'm going to get 22.2 days. And then I'm going to take 16.8 and subtract 2 times 2.7. And I'm going to get 11.4 days. Okay, so if we have more than 22.2 days or less than 11.4 days, then it's unusual. Okay, all right, guys, have a great day. I'll talk to you again soon. If you have any questions, please let me know. Hope to see you soon. And remember, wash your hands, social distancing, and we're going to get through this together.